All right, now in this lecture, we are going to cover the errors in measuring behavior. And you see that they come from many sources, so we'll go through each one of them. Okay, now there are really two types of measurement errors. And so one is biases, another one is random errors. Okay, so you'll see that biases are usually validity related as opposed to random errors are usually reliability related. Okay, so biases are systematic errors. So which means that it is kind of happening all the way throughout the entire study. Okay, now this can really push the results either way. So it can make you make either a type 1 error or a type 2 error. Okay, so now the example of biases are things like experimental effect, demand characteristic, reactivity, social desirability, and placebo effects. Okay, so because these are generally applied to either every person in the entire study, or worse yet, it is systematically applied to one group of the study or one condition of the study. Okay, and that is going to be a huge problem in when it comes to affecting aspects of the validity of the study. Okay, now let's talk about what is observer bias. Well, observer bias are the bias that are created by the observer. Okay, so the observer are usually because they are part of the experimenter. Okay, so they usually know what is the intended hypothesis is. And when they do this, they might consciously or subconsciously help out with the experiment results. Okay, so the example here that you give is that I give you is that you as an observer knew beforehand that you're observing patient with depression. So you rate these people much higher in categories such as sad, moody, brooding, and suicidal. Well, now, what is the best way to remove that? Well, the best way to remove that is you have the observer observe both the control group as well as the depressed group, and then you don't tell them which group is what. Okay, so you essentially blind the observer. You don't tell them the identity that say this person that comes in has previously been diagnosed with depression. You just don't tell them. You just tell them this person is coming in. I want you to take a look. I don't want you to have any preconceived notion about them. And after you talk to them, well, after you watch the video, let me know what your impression is. You know, so you want to give them as little information as possible. Okay. So how do we eliminate this? Well, you can just put them. You can blind them, like I said. Okay, that's essentially what this is saying. You get the observer who are unaware of what the aspect of the subject they will be observing. Okay. And that is calling blinding observers. Okay, now reactivity. So what is reactivity? It's basically when the subjects they realize that they're being observed and therefore they change their behavior. Okay, so this is kind of very similar to having a camera on a person, and the moment that a person know that they are being recorded and then they start to fidget and then they feel like, oh, I'm not feeling like myself, and then you can see that they get very awkward in front of the camera. They are not being themselves anymore, and that would be reactivity. Okay. Now, what are the two ways to overcome this problem? Well, the two way to overcome this problem is you can record them without them knowing. Okay, you see a lot of people do that on YouTube, especially when they are pranking someone. So therefore, they get them like the most real reaction out of them. Okay, that's one way. The second way is you constantly have a camera or an observer that is around so much that they get desensitized to it. And then once they get so desensitized of having a camera or having an observer right next to them, they becomes like just so desensitized to them, and basically they start to acting like themselves again. Okay, that is a process called habituation or desensitization. Okay, now, so having unobtrusive measurement, this is something very similar to having a hidden camera. Okay, so this is when the subjects are unaware, and this is also called blinding the subjects. So by using this blinding the subject, you can reduce demand characteristic and social desirability effects. So which makes sense, right? Because the moment that they know that they are being observed, they think that, okay, the experimenter wants something out of me, therefore I should change my behavior. Well, that's not good for the realness of your study, right? And then, or they might think that, oh, okay, I'm being observed, I must make myself look socially proper, and therefore they might also change the behavior. Okay, so that would be the social desirability aspect of it. Okay, now, both of these are subject biases, okay? The main characteristic, as we said, when subjects catch on what your hypothesis is, and then they deliberately try to help you out with the results. Whereas the social desirability is when subjects lie and give you a more socially accepted answer. Okay, so example of that would be something like, let's say, when is the first time that a person had sex? Okay. Now, guys, they might give you an answer that is younger than when they actually had the first time when they had sex. Okay, something like that. And that's because they didn't want to make it seem like they lost their virginity at like age of 25 or something like that, which is, of course, there's nothing wrong with it. It's just that in college or in high school, it just seems like in guys that is more socially accepted if they had some sort of sexual awakening in the earlier age. But I have no personal opinion on that. Okay, so I'm just saying that this is what the society is more um, find that desirable. Okay. All right. So now let's talk about random errors of measurement. So random errors are inconsistent with non-systematic errors in experiment. So things that you mistakenly marked a subject down as male when it's a female, okay, or you mistakenly marked everything in the wrong column and when you're analyzing data. So these are things that kind of happen in a blip, okay, or something like copy pasting error. These are all like random errors of measurement when you are trying to do an experiment. Okay, now, so random errors are really going to impact the reliability. Okay, now as we said before, the systematic errors, most likely they are going to impact the validity of the study. Okay, now, so what is the reliability of the study? Well, it's basically the extent to which the measure produces stable and consistent results. So imagine reliability as uh, imagine a study as like a scale. Okay, now every time I step on it, it's going to say that I weigh 150 pounds. 150 pounds, 150 pounds. All right, the 50th time I weigh myself, it still says 150 pounds. So that is a very reliable scale. Okay, it's the fact that it gives you stable and consistent results over and over again. So now reliable studies, which will mean that this is not influenced by random errors. And usually standardization increases reliability as well as internal validity. Now standardization, why does this increase reliability? Because it has a protocol in which that you do this first, followed by this, followed by this, followed by this, followed by that, followed by that, and you are instructed to do this exactly the same order, exactly the same over again. So this increases the reproducibility of the actual study. Okay. Okay, now a study can be reliable but not valid. Okay, now imagine if an instrument that is every time that I step on the scale, it tells me I'm 10 pounds, I'm 10 pounds, I'm 10 pounds. I measure 150 times, it tells me that I weigh 10 pounds. Well, that's very reliable measurement, but it's not valid because there is no way I weigh 10 pounds, right? So so you see that a study can be reliable but not valid. Okay, so in essentially you want to think of it as reliability as the precision of the measurement, okay, and validity as the veracity or the truthfulness of the instrument. Okay, now you probably already make the link that reliable instruments is not necessarily valid, right? And but a valid instrument is has to be reliable. Okay, so because if something is unreliable, let's say a scale that tells me five pound, I weigh 5 pounds, and next time I step on it, it tells me I weigh a ton, and the next time I step on it, it says 150 pounds. You know, it's just giving me all these different numbers. Can it ever be accurate? No, it cannot, because it's so a reliable measurement is never valid. Okay, and therefore a valid measurement is always reliable. Okay, now a however a reliable measurement is not necessarily valid. Okay, so just get those ideas in your head. Now, reliability is usually expressed in correlation coefficients. So this is very similar to the way that it is correlation. Okay, so this is very similar to Pearson's R, as you guys remember this. Now, why is it expressed in R? Because what it does is it usually takes the first time that the experiment was done and correlate with the results when the second time, with the third time, when the fourth time that it was done. So this is why reliability is usually expressed in correlation coefficients. Okay, so when you kind of think about it, the amount of the random error would be kind of the part that is absent in making the entire study whole. So in other words, when you have 1 minus the random error, that would equal the reliability. Okay. Okay, now test retest reliability is essentially that you did the test the first time, and then you're looking at the second time, and then you're seeing how much the first results correlate with the second result. Okay, now so this is the extent to which the experimenter administered two identical experiments over two different periods of time and correlate the results. Okay, and the practice effect can boost the reliability in the wrong way. And then, so when you kind of think about it, test retest reliability, because you are doing this exactly over the two periods of time, right? So if so this is indicator of time sampling error. So what is time sampling error? Well, so time sampling error is basically when the passage of time goes on, how likely there are like errors that are involved with it. All right, so In other words, if you have a high test retest reliability, then that would mean that you have low time sampling error, and vice versa. Okay. Now, inter-observer what inter-rater reliability. So this is so imagine if um, I'm sitting in front of a New York library, and then another person who is sitting right next to me. We are both watching what is going on, and then we saw an incident. It doesn't matter what incident, okay? And then we are watching exactly the same incident, okay? But we caught different things. Our eyes caught different things. And then the way I interpreted the event is blah, blah, blah. And then my friend who's sitting next to me, who witnessed exactly the same thing, who he had a different interpretation of the event. Okay. And then we're talking about that, and you think, and we're just kind of comparing what we just saw, be like, no, no, that's not what happened. And then he's telling me, no, 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 that's not what happened. Okay. So the discrepancies of us, the interpreter, with the observer, that we're looking at exactly the same event, and then we are reading the event very differently. So now in something like this that happens, that's because we do not have we were not trained to look for exactly the same thing. Okay, and that is causing us to have different opinions regardless have witnessed exactly the same thing. So that would mean that in the case that I just told you guys before, that would mean that our inter-observer reliability is very low because we cannot agree on the subject on what we witnessed, despite the fact that we witnessed exactly the same thing at the same time. Okay, now standardization and training of observer can really improve the inter-observer reliability. Okay, now the inter-observer reliability also puts a ceiling on the test-retest reliability. Just remember this, okay? Okay, so here give you a scenario. So in a study where the observer determines the score of the participants, you perfectly standardize how you administer the measure. You notice the way participants behaved on the retest is exactly the same as how they behaved previously. It looks like the test retest reliability is 1, right? And the question, and then the answer is no, okay? And because you used observers, okay? And it doesn't really necessarily mean that they will give you the same true behavior of the same score over the different trials. So it really depends on the observers. So now you're probably thinking that what is the best way to really uh, make sure that you have very good inter-rater or inter-observer reliability. Well, you can use just one person. Okay, you can use one person from the beginning to the end. But that means that the workload from this one person is astronomical, of course. And another way that you can do this, as we said before, you can train them, and then you can run a small pilot of studies in which that you have the 2 or 3 or 4 observers that rate exactly the same event and then you're trying to have them be as consistent to each other as possible. And after you run this pilot of studies, let's say if your inter-rater reliability is, let's say, 0.95, which is very, very high, okay? And then you can let them go and then analyze different aspect of stuff that's going on in the experiment. But over time, you still need to have them reconvened and then have them go over and retrain them, okay? Because people after they have not been retrained in a while, they tend to go astray from what they were training before. So it's very important to kind of to reconvene them and retrain them from time to time. Okay. Okay. Now the next part I want to talk about is internal consistency. Okay. So now this is the extent to which the study are measuring the same thing. So this is the homogeneity of the items. All right. So now, uh, when something is internally consistent, this is indicator of high reliability as well as high validity. Okay. Now, vice versa, low internal consistency is an indicator of low reliability and low validity. Okay. So to conclude, so reliability is a prerequisite of for construct validity. Okay, test retest reliability tells you the extent of which random error is influencing your measure. Okay, and just because a measure is reliable doesn't mean that it is for sure valid. All right, for the next part, we're going to talk about control. Okay, so what is control? So it's basically any means used to rule out the threats of the validity of the study. Okay, and then the control things, the common things that you see is control group as well as the control condition. All right, so the control condition is basically when a subject use themselves as their own control, which involves some sort of within subject's design study. Okay, now uh, control group up here is obviously when it means that there are another group, either you might call it the treatment group or the experimental group. So that will be the group that gets the actual intended treatment. Okay, so a control group basically, now there are many kind of control group, but then when we are just kind of talking about control group, we are really just talking about a group that receive basically nothing or a bogus treatment. Okay, a treatment that is known to have no effect. All right, so the control group is used in between subjects design when there are two or more independent groups. Okay, so now as we said before, there can be various form of control. So there can be an empty control group, there can be a negative control group, and there can be a positive control group. So empty control group is basically a control group that received no bogus treatment, not even like a sugar pill, not even something like that would give you some sort of mental suggestion. Okay, so essentially empty control group is not the most ideal kind of control group that you should have. The most ideal kind of control group that you should have is the placebo control group. Okay, which you might also hear it as a negative control group. But I'm going to say as a placebo control group from now on. Because the placebo effect is essentially an effect that is the power of the persuasion. And then with this persuasion can really make you think that the treatment, the bogus treatment that you're getting has some sort of effect. And therefore your mentality and all these other stuff uh, start to change. Okay, now positive control group is something that you are getting based on the previous experiment that you know that this is something is supposed to work. Okay, and we're going to talk about what the control are really telling us when we get into the later lectures. Okay, empty control group. As we said before, this is a serious issue. And then the reason why it's a problem in research is because of the placebo effect. Okay, when people are told that they're getting a treatment, even when they do not know that this is a treatment that is not supposed to work, such as like a fiber pill or like a sugar pill, is something like a water pill, okay, something like that. But if you were given a water pill and you tell and people tell you that there is something in this water, that is supposed to work, is supposed to make you, just so much smarter. And a few, I mean, not a few, but a lot of people are going to start to believe that, and therefore they are going to change their behavior as a result. Okay, and then from there, that may become like a positive or a negative like mental loop, and it just keeps coming back to feed that original notion of the placebo effect. And you're just thinking that because the mind is a very powerful thing, and then the mind can also be easily persuaded, and therefore the placebo effect can really induce someone to, well, it can really induce someone to change the behavior. Okay. All right. Now, the placebo control group. So this is why it's always important to have a placebo control group. So this is a group that received the same thing, except the manipulation itself. So the example of that would be you're interested in the caffeine's effect on attention. The group that drank the decaf coffee is the placebo control group. Okay, so that would mean that experimental group is the one that drank regular coffee, because it could be the fact that you are drinking coffee, maybe the smell of the coffee, maybe the fact that you are just drinking a hot liquid, that is triggering something inside you that is making you behaving differently. Okay. Okay, so now the positive control group, as we said before, this is the group that received the treatment that is previously known to cause an effect. Okay, now you can also have the subject as their own control. So this really only applies to within subject design, or you might also know it as the repeated measure design. So this is essentially when one subject goes through many, many phases, okay, many levels of the experiment. Okay, so now sometimes it's not logical, or sometimes not. It's not possible to do this. For example, the learning paradigm or manipulation that has a long-lasting effect. Now imagine if something that so let's say in learning paradigms, after you learn something, can you unlearn it? Well, you really can't, right? So therefore, it's not ideal to use a subject as their own control group in this case. All right, or let's say the manipulation that has a long-lasting effect. So let's say, for instance, you are trying to see if a person after they ingest something, a drug, penicillin that were to cure, let's say, a certain disease. Well, once they are cured, you cannot uncure them and bring the disease back. Well, I mean, actually you can, but it would not be ethical. Okay, so subjects as their own control have their own limitation as well, and these are usually stuff that is just not logical or not possible to do. Okay. Now, how do you make sure that the groups are comparable to start with? Well, this only applies to between groups design. So you want to make sure that the control group and experimental group at the very beginning, they start at the same place. Now, because what happens is that if they start at different places, then you really don't know if um, the differences that you're seeing afterwards, is this because due to the experimental manipulation, or is it just due to the fact that they were just innately different two groups, right? So you can use random assignment, okay, or you can use matching. So these are the two ways that you can make sure that the the two groups are comparable to start with. Okay. Now, what is random assignment? So essentially, random assignment is um, assignment of the subjects to condition. Okay, so let's say you are interested in knowing something. Okay, let's say effect of caffeine on attention again. Okay, and then you are essentially going to get a group of people that are going to be in a control group that drinks decaf coffee, and then you are going to have another group, the experimental group, of the person that who are going to drink the regular coffee. Well, how do you make sure that the person, that the pool of the subjects that you gathered, who goes to the decaf group and who goes to the regular um, coffee group? Well, the only way that you do this in random assignment is they should all have an equal chance of becoming in being assigned to the condition. Okay, so the way that you do this is usually by the flip of coins, or you have the subjects draw out their numbers in a hat, something like that. So it should be something that is random. Okay. Okay, so then the only way that confounding of the subject variable with the experimental variable can occur is by chance. So you can see that this pretty much have, if there's any subject related variables, when you do random assignment, that you essentially scatter that throughout the groups, and then there should be more or less more evenly distributed throughout the experiment. Okay, basically. Now, an alternative strategy to make sure that the two groups were just like any groups before the experiment takes commence is comparable, you can use matching, but that would require that there's some sort of pretest. Okay, pretest meaning that before manipulation has occurred, you give them, you get a baseline of what they are, and then what you would do is you would match them based on ranking. Okay, and this is usually when the random assignment is not ideal. And the what you see a lot in matching is that when the subjects are just you have a very low number of subjects, such as, let's say if you had 10 people in the study, and then there are two groups, and then you need to you will only have a group an n of 5 in each group. Well, that's a very low that's a very low number. Okay, and then therefore random assignment is not going to be ideal. So in this case, it's better to do something like, let's say, a matching. Okay. Okay, and another thing that you can do is you can build a nuisance variable. Okay, so this is a condition experiment that cannot be easily removed from the study, so it's made an independent variable as a means of control. So the example that give you here is that, okay, so you're interested in caffeine's effect on attention scores. You are testing over N of 300 patients, so it would take weeks to test them, but you are worried about the time of the day confounding the outcome. Okay, so that would mean that because you're testing people around the clock, right? So some people who are going to be tested in the morning, some people are going to be tested at night, and some are just in the middle of the day, right? So then, therefore, then what you can do is you can make the testing time, okay, such as the morning, afternoon, and at night, a nuisance variable. Okay, now, sometimes a nuisance variable may become something that's very interesting. Okay, so let's say for the example here, you could be looking at something like the effect of caffeine on attention is more pronounced in the morning, but not so pronounced in the afternoon and becomes pronounced again at night. So that would mean that there is some sort of interaction in the time of the day that is interacting with the effect of caffeine on attention scores. So building a nuisance variable in the entire study is actually not a bad idea. Sometimes it might actually makes it more clear to really make a good idea to kind of see how the variables interact with each other and how they collectively may affect your dependent variable. In this case, what that would be the attention scores. Okay. Now, with all of these said, you should be well equipped to try to attempt your homework number 1 and 2 in workbook. Okay. Now, the answers will also be given in the link to the YouTube channel, and just look for it in the content folder. It should be in the same content folder in the week 2.